And it's recording. Here we go, let's begin. So, exercise 1F is finding the equation of a straight line. So I've demonstrated so far that in the previous exercise, you had to learn to identify M and C. And then what we're going to work through today is now developing the equation. So if you type on Desmos, it should do what you want over here. Okay? Let's recap. What is M again? Can I please have? Let's go with Andrea. What is M? It is the gradient. What is the definition of the gradient that you've been given? Can I please have? Let's go with Raha. Rise over run. Very good. Rise over run, and then I gave you a formula to solve it. So these two examples, you're going to need that formula to solve. What was the formula again? Let's go with Toby. I'll give you a hint. Y squared? No. Oh, I think I understand what you're saying. Y2, do you mean? Okay. Well, someone else carry on, Samvi? All right, make sure to copy this one down because you're going to need this for today's lesson. And then I gave you an extra one, which I kind of extended you, and then I might have confused some of you, which you don't need to know. I'm going to use it in a different color. It can also equal to, anyone remember? 10 of an angle. When you type on your calculator, 10 of whatever the angle is, that is technically, whatever the answer is giving to you, it's giving you the gradient, okay? So if you want to know what the gradient is, if you had a horizontal line like that, and you made 30 degrees, and you want to know, well, what gradient is it? What's the ratio of your horizontal by vertical line, or length? Type on your calculator, 10 of 30 degrees, whatever that number is, that's the slope, okay? That's the gradient ratio. All right. But like I said, it could be useful for you next year, because you guys, if you do the 10 accelerator, I'm pretty sure you'll start working with those kind of properties. Next one, what does C stand for? What does C stand for? Let's go with Yuna. The y-intercept, very good. And Nishi, how do you find the y-intercept? Very good. So the y-intercept is a coordinate on the y-axis. One of the things we know is that no matter which point you pick on the y-axis, x is always 0, just by coordinates. And therefore, that's why the theory your teachers normally say, let x equal to 0. So if you want to find y-intercept, you're going to let x equal to 0. These are the only two things you're going to be applying in this exercise to find the equation of a straight line. They'll give you all the other pieces. Sorry. Yes. Anyone else who hasn't got a sheet yet? Pass this along. Can you pass that down to some students who may have just walked in? Just pass it down. And let me just fix the roll. I've now got Shell and who's Andrea? That's all right. I'll fix it later. Okay, let's do this example. So, this question, I can take it from just finding the gradient between 2 points, but then I can also develop a straight line equation from it as well. So the first step is you need to find the gradient. Now, I'll show you here. So again, the equation of a straight line, any straight line is always y equals mx plus c. The first thing you'll need to find is m, usually, okay? And to find m, we already have the definitions here. They have to give you some points. Okay, remember, how many points minimum do you need to draw a straight line? 2. So that means they have to give you 2 points somewhere. And if they don't, well, then you can't really solve for m, okay, unless they give you something else like an angle. So at this point, they have to give you 2 points. In this case, they did. Imagine they're saying there's a straight line that will pass through 4, 2 and 12, 4. What is that equation of that line? So if I show you visually what I'm trying to explain, let's go to Desmos. So if I go to Desmos right now, let's have a look at Desmos. I cross this off. 4, 2, and the other one is 12, 4. Yeah, 12, 4. I'm just going to take off the grid so it doesn't look too confusing. Yeah, maybe that's better. These are your 2 points. We need to come up with a straight line that will cut through those 2 points. So if I came up with a number right now, so y equals, my favorite number is 3, so 3x, and let's say plus 1. Clearly, that line doesn't cross through it. What you're going to do is you're going to go through some algebra. You're going to solve for m, and then you're going to solve for c, so that it does cross through these 2 points. It's only 2 steps. First one is find the gradient. So let's find the gradient together. Here we go. To find the gradient, you told me before the formula is y2 minus y1 divided by x2 minus x1. Right, really it's just the distance vertically and distance horizontally. That's what it is. You're just finding how far is it from the final to the initial. That's why it's your rise and your run. Okay, so you pick 2 points. So here you've got 2 points, and it doesn't matter which one is y1 and which one's y2. Because it's a ratio, it's going to be the same. The answer is going to come out the same. It doesn't matter which one you pick. So you can try it if you like. So I usually just like to work from left to right. I just go from left to right, so let's call it x1. I'll call this the first point, so x1, y1, and this one can be x2, y2. Now if I followed that, then y2 would now be 4, take away y1, which is 2, divided by x2, which is currently 12, take away x1, which is 4. So I'll repeat what I'm doing. I took y2, take away y1, so that's 4 take away 2 on the numerator. x2 minus x1, so it's 12 take away 4, 12 take away 4. And again, just repeating, why is this x2 and y2? I just happen to pick it. It could have been the other way. Okay, it could have been x2, y2, x1, y1, doesn't matter. The answer is going to be the same. Okay? Now, the common mistake that I see students do for the first time if they're learning how to find the gradient, common mistake is that they write y2 minus y1 on the bottom. Okay, and I think it's because with the order of our alphabets, we're used to x then y, and so that's why they often do x's on the top and y's on the bottom. So that's one common mistake, even though the formula's right in front of them, even though they label it, somehow they still get the wrong answer. So just pay attention to which one's your y's and which one's your x's. Okay, let's solve for it. 4 take away 2, which gives you 2. 12 take away 4 gives you 8. But let's simplify that. What's 2 over 4? I mean, 2 over 8 simplified as, let's go, Joanne. 1 quarter. So I'm going to go back to Desmos now. And I'm going to type in, I now know the gradient. So y equals, instead of m now, I know that is a quarter. So it's a quarter x. I don't know what the y-intercept is. So this is what it looks like. If I go back, here's a quarter. Oh. I happen to actually got, now you know what C is. Well, it's a quarter x. Problem is we don't know what C is, right? It's on the correct slant. So that slant should be the correct slant to touch these two in the same trajectory. What we have a problem with is the y-intercept is currently at 0. But we need to change the y-intercept so that it can move up or down, because the y-intercept can be at -1, -2, -3. It can keep going down, it can keep going up until it touches these 2 points. So you can do a trial and error on Desmos. If I did -1, you can see it's getting further down, further down, further down, further down, further down, further down. Obviously, we want to be adding. So likely the C value is going to be a positive number. I don't want you to trial and error. We're going to use algebra to solve it. So here, how do we solve for C? Well, if you look at the equation, you found M. Remember, that's a parameter. These are variables, so they change. So you have to look at what they've given to you. They've given you 2 points that this rule must follow. This rule is y will equal to whatever m is, times that to the x, and then you add c. Now, the point tells you want when x is 4, y is 2. That means you can sub one of these points in. You can say when x is 4, y needs to be 2. Or you could also say when x is 12, y needs to be 4. Because we're saying the rule needs to fit those 2 points. So that means when you sub it in, it should work. So let's test it now. So I can pick either one. I would probably pick the one with a smaller number because we're doing multiplication, addition, subtraction. It's easier if it's smaller numbers. So I'll probably sub 4-2 in, but you could have tried 12-4 and you would get the same answer. Okay, so here we go. I'm going to now say, so the second step, this was first step, find the gradient. Second step, sub a point. Just by the time you get to year 10, 11, and 12, please don't just sub any point. You have to do a bit of thinking. It's a point that works with the rule. Because there's a lot of points later on that they'll give to you, but there's only one or two that fits the rule. So you have to read the question. If it says this is going to cross through, passes through, or this point is a part of this line, that's when you sub it in. It doesn't make sense to sub a different point for a different line into this line. Okay? So here I'm going to sub in a point, and I'm choosing 4-2 just because the numbers are smaller. So this gives me now y is equal to, so remember this is y and this is x. So y is 4, m, which we worked out before was a quarter, times x, which we now is, oh sorry, I got it wrong. That's 2, y is 2, x is 4, and then we're trying to solve for c. So I subbed in y is 2, x is 4, m, which we worked out before, which is a quarter. Now you only got one unknown that you don't know, and that's what you've been training before prior to the last two exercises, or today's and yesterday's exercises. You've been working on solving linear equations. That's why you've been training to do fractions and all that, is because you can get a variety of samples. And you have to be confident that no matter what I give you, you can solve for an unknown. That's why you've been doing so many different examples on solving, yeah? So here, hopefully you know your fractions. What is a quarter times 4? Can I please have Sean? What's a quarter times 4? 1, very good. If you didn't know, you can change 4 to a fraction. So it's 4 over 1, and then 1 over 4 times 4 over 1, top to top, bottom to bottom, and 4 divided by 4 is 1. Okay, so that's practicing fractions. I'm assuming by the time you're in accelerated group, your fraction's okay. If it's not, make sure to practice, okay? And then the next part here is this is 2 plus, and that's a plus c there. So 2 is your y, quarter times 4 is 1, or quarter of 4 is 1, plus c. So to find c, I need to get rid of the 1. How do I get rid of the 1? Let's go with Cassidy. What do I do to get rid of that 1? I need to solve for c, I need to get rid of that 1. Beautiful. Take away 1 on both sides because that's a positive 1. So 1 take away 1 cancels out. That's why you're left with just c. And then on this side, 2 take away 1. That tells me c needs to be 1. Notice my layout, vertical layout. That's how you should be laying it all out. Every time you're solving, it should be a vertical layout. So what we figured out now is m is a quarter and c is 1. So your equation should be a quarter y equals to a quarter x, and we said positive 1, and it does work. It crosses through those 2 points without trial and error. We are able to solve for these 2 points by finding the gradient, and then one of these points have to fit on the rule, right? The rule says it has to fit these 2 points, hence why you can sub either point and you should be able to get C. Does that make sense, Raphael?
Understood.
Okay. All right. I'm going to give you, because this is your first time, I'm going to give you a bit more time. Let's give it 5 minutes. I want you to solve the equation for the next one. So same idea. You got -2, -5, -4, -2. I'm just going to pause the video. And it should be continuing. I think it is. Anyways, this is your exercise for today. So exercise 1F is doing what we just did. That's fluency. Okay, so that's the ability to find the equation of a straight line. Once you're feeling confident in that, which is doing the gradient and then finding the y-intercept, the only errors that you might get along the way is your layout. Okay, are you making negative mistakes? Check with your calculator, check your answers as you go. Once you're confident with this skill, then I want you to start doing problem-solving questions, which can you turn to the back of your sheet? It's the same idea, but this time they're modeling it. Okay, so turn over. Let's do this example. Here we go. So this is from exercise 1G, question 7, problem solving. Same idea. I think it's 1F, sorry, my bad. The cost of hiring a surfboard involves, listening. Thanks, team. So The surfboard involves an upfront fee, so it means you have to pay them first. So upfront fee plus an hourly rate. So if I want to hire this surfboard, I need to give them a certain amount first, and then after every hour, I have to pay them a certain fee. Okay, so there's a rate per hour. 3 hours of hire cost is $50, and 7 hours of hire cost is $90. This is a problem. What they haven't done for you is they haven't modeled it into an equation for you. You have to create the equation yourself. Okay, so unlike before, you've got y equals, etc. They gave you coordinates. Now they don't. Now this is a sort of a hypothetical situation which you can think of. If you went to hire a surfboard, usually it could be a $5 entry to get into a certain area, and then an hourly rate that if you're going to hire the surfboard for per hour, it could be about $20 per hour. And then if you hire it for 2 hours, it's $40. So how much would you pay overall? Yeah, you're going to model this. Now this particular person, they hired it for 3 hours. It costs $50. This person has hired it for 7 hours, and it's $90. So what is the rate per hour, and what is the cost upfront? That's what we're trying to figure out, right? So here, to do this, part A, we need to first model this. So let's say they've given us C is the cost and T is the hours. So that means cost, which we don't know, will depend on how much they pay for upfront plus certain amounts of rate. So let's call it M per hour. So I don't know how much they're charging per hour. T is for hours, time in hours. Okay. Upfront is obviously a static amount. So if you look at this equation, hopefully you can see the link to y equals mx plus c. You start to see it? That thing? This is very similar to how we normally model the problem. Y is equal to, this is your mx, and this is your c. C is static. That is the starting point. Your y-intercept is usually your y-axis. It's your starting point. So it's your upfront fee. We don't know what the rate is, and the rate is the rise on run. It's rise per run. Well, this is cost per hour. It's the same thing. Yes, speed is the same. 60 kilometers per hour. It's a rate. M is your rate. T is the actual time you want to hire. So here, what they're telling you is that if you spent 3 hours, the cost would be $50. If you spent 7 hours or hired it for 7 hours, it would be $90. So what they're trying to tell you is that you've got two coordinates. When T is 3, C, the cost has to be 50. When T is 7, the cost has to be 90. If you've got that sort of logic of what's happening, you can do exactly what we just did to find the equation and figure out how much is the upfront fee, which is your y-intercept, and you can also figure out the rate per hour. So using these 2 points, you can figure out the rate. Okay, so you can work out per hour how much does it cost. If it takes 3 hours to get $50 and then 7 hours for $90, you can do that logically, right? But we can use our rule. Let's use our rule to find M, to find the rate. Let's work out the rate. If you want to work out the rate, you can call this T1, or I'll just make it X1 just to make it easy for you to understand. X1, Y1, X2, Y2. Here we go. The rate should equal to Y2 minus Y1 over X2 minus X1. Y2 is currently 90. Take away Y1, which is 50, over 7 hours versus 3 hours. So this is your average rate. Your rate is 90 take away 50 is $40 per 4 hours. So if you had to work that out, $40 per 4 hours is actually how much per hour? What's the rate per hour? 10, logically. So we know when we say rate is $10 per hour, that is your gradient. That's what a gradient means. Gradient is a rate. It's two variables. Yeah, we're comparing two variables. So that means, back to our equation, I know the cost is equal to $10 per hour plus an upfront fee. I don't know what the upfront fee is. That's your y-intercept. That's your starting point. Using what you've learned so far, step one was to find the rate, which is gradient. How do you find C again? How do you find y-intercept? What do you have to do? What were you doing just then? Yes, Anvi.
You have to substitute the numbers and then find the y-intercept.
Exactly, because this is our rule. We know it's $10 per hour, and you've got the information. You know, if you spend 3 hours, $50. If you spend 7 hours, it's $90. That's true. We just don't know what the upfront fee is, but if you got the rate, you can figure it out. So here we go. We say, all right, well, if it was 3 hours, the cost should have been $50. So you can work backwards and figure it out. You can say, well, $50 and it's $10 per hour and I had 3 hours on it. We can work backwards to figure out the upfront fee. $10 per hour and you spend 3 hours, well, that's $30 already. That's $30. So your upfront fee has to be something to make up that point there. 30 plus something has to equal 50. So you can work backwards and figure it out. So the upfront fee has to clearly be $20. So if you put it all together, you can model this situation now. You can model it and say, oh, well, the cost, if you're going to go to this surfboard shop and hire, you know the cost would be $10 per hour plus a $20 upfront fee. And now you can predict. You can say, well, if I didn't want 3 hours and 7 hours too long, what if I only have time for 1 hour? How much would it cost? So logically, if it's only 1 hour, you pay $10 per hour plus an upfront fee. Well, together you need $30 to do that. But you can chart this. You can visually see what it looks like. Now here's a problem when you do applications. Does it make sense if I do this? I'm just going to take this off. So you had 3 hours and that was $50. I'm going to put it here. You had 7 hours and it was $90. I'll put it there. And then this is your equation. You had y is equal to 10x plus 20. Now I'm going to zoom out so you can see a couple of points. So here we go. Does it make sense if I took this picture? Actually, I'll just change the axes so that it's a bit easier to see. Let's go with negative 20 to 20. And yeah, that's okay. So, does it make sense if I copy this picture and then put it into this page and sketched it here? What's the problem? There's something wrong already. Anyone see something wrong with the graph? We're talking about realistic here. We were trying to model a problem. What's the problem? Exactly. Does it make sense that your upfront fee was at 20? How does it make sense that you have this side of the equation? What is this cost? So at $15, you've got negative hours. Yeah. What does that even mean?
If you're hiring a surfboard for negative hours, then they have to pay.
Oh man, yeah. That's it. If you're hiring, that's what I'm saying. So I guess that's what the negatives are important. So when you first learn negatives, teachers don't normally explain why do you use negatives. And in that case, yeah, you could talk it about in the reverse. So they have to pay you back or you pay them back. That's how money works. Yeah. So in this case here, if you were doing your exam or application, we will penalize you if you continue on the graph, because it doesn't make sense to have one negative time. It doesn't make sense that your upfront fee was exactly at 20. How are you paying any less than that? That doesn't make sense. So your graph should have started at your y-intercept, which is 0, 20. Your y-axis was the cost. This is your t in hours. And then you draw your points. So you draw out your straight line from here, and then you can label it. You can put a point here and say when it's 3 hours, it's meant to be $50, and draw an arrow. It just means that, well, obviously there's also an upper limit. Anyone know what the upper limit is? Yeah. Usually in the exams, they would have told you that it would be limited to, between 7 a.m. to open time to closing time. And that's implicit. So my year 12s have to read the question. Notice that it's 7 a.m. to 7 p.m., for example. That's 12 hours. So on the x-axis, they have to do it from 0 to 12. So the examiners won't tell you. You have to figure it out yourself that there is a limit. Otherwise, if I draw an arrow, that implies that I can hire it forever. infinite, right? So that's the application part, but before you do the application, you have to know the skills. Okay, so I'm going to stop my video there today. Learn the skills first, fluency, before you apply. All right? I'll stop.